September 2015, question 8. Two resistors, each of resistance 2 ohms, are connected in parallel to a 6-volt battery of negligible resistance. In circuit 1 below, S1 and S2 are two switches connected in the circuit as shown. So when both of these are closed, these two are connected in parallel. The total current will flow in this direction, I total, and at that junction it will be divided, I1 and I2. Then the total current will combine, so will form I total again, 8.1. What is the reading on the voltmeter in circuit 1 when switch S1 and switch S2 are both open? So when these two are both open, there's no current that's flowing in the external circuit. So the voltmeter will register the value of the EMF. So this is 6 volts, 8.2. With switches S1 and S2 closed in circuit 1, determine the reading on the ammeter. When we close these two, so the EMF is equals to I R plus R, where the internal resistance is 0 ohms, because we are told that it has negligible internal resistance. So the internal resistance must be 0. So the EMF should be equals to I total multiplied by R external. We already have the value of the EMF. We just need to find R external so that we can calculate the current. So R parallel is equals to your first resistor multiplied by your second resistor, and then you add the two. So this is going to give me 1 ohm. Since these are the only two resistors that are connected in the external circuit, that will be R external. The value of the EMF is 6 I multiplied by 1. So the current should be equals to 6.0 amperes. Circuit 2 below is identical to circuit 1, but the 6-volt battery has an internal resistance. Okay. When only switch S1 is closed in circuit 1, so we are closing only switch 1, it means that no current will come this way. So we can essentially just remove this part. The total current will go like so. Its ammeter reading will be the same as the reading on circuit 2 with both its switches closed. Okay, 8.3. Calculate the internal resistance of the battery. We are going to start with circuit 1. Remember, in circuit 1, there is no internal resistance. Our R external is going to be equals to 2 ohms because there's no current flowing in this part of the circuit, so we only have one resistor. And then our EMF will represent our external voltage, which is equals to 6 volts, which means we can find the current, V over R. So V is 6 and R is 2. So the total current is 3. And then we are told that when only switch S1 is closed in circuit 1, its ammeter reading will be the same as the ammeter reading on circuit 2 with both switches closed. So the total current there is 3.0 amperes. And then we also have internal resistance, and then we are closing both these switches. So we will have I total, I1 and I2. So the current is divided. Circuit 2. R external is equals to the parallel combination, and we already know that the parallel combination is going to be 1 ohm. And then the value of the EMF is 6 volts. The total current is equals to 3.0, and then the internal resistance, that's what we are trying to find. The EMF is 6, the current is 3.0, R external is 1. Then so the internal resistance should be 6 divided by 3 minus 1, which is 1.0 ohms. 8.4. Consider circuit 2. How does the voltmeter reading when both S1 and S2 are closed compared to when only S1 is closed? Write greater than, same as, or smaller than. So when both of these are closed, we need to compare what the voltmeter reading will be when only switch S1 is closed. Of course, here we have a parallel combination, so the R external decreases, because in this circuit R external is going to be equals to 1.0 ohms, but in that one R external is equals to 2 ohms. So R external decreases, the current increases, and then okay, let's just answer 8.5 so that it becomes easy to know what's happening here. Explain the answer. So R external decreases, so the current increases, the EMF and the internal resistance do not change. So when the current goes up, we expect V lost increases and V external to decrease. So the answer there should be smaller than.